I'm J.B. Tate. I'm part of a group to interview Jim Dellinger this morning. We're out here at New Riverside Ochre at the main building. And we have a lot of questions that we want to get on record with Jim about his family and himself and the nature of his business here. So let me start by talking with Jim about his family background. Jim, give us a little sketch about the Satterfields and the Dellingers, if you will.
Certainly, J.B. I don't know how little it might be, but we'll get started anyway. My great-grandfather, George W. Satterfield, was in the mercantile business in Cartersville, Georgia. And this is back in the 1800s. And his store is located right across the railroad tracks in Cartersville, downtown Cartersville. It's a two-story building that's across the railroad tracks from Young Brothers Drugstore. And it's where Sweet Market is now located. And that's always been known as the Cowan Building for a long time. You know, why, I don't know, because it was originally the Satterfield Building. But they were in the mercantile business there, and in the late 1800s, people got to start mining. In the early 1800s, they were mining a little iron, but the ochre mining kind of started up a little bit, and my great-grandfather got interested in it and started buying up properties, some of them at the courthouse, you know, where he thought there might be minerals, principally ochre, all right? And he had three sons. One of them was my grandfather, Will Satterfield. And they started Riverside Ochre Company. Not New Riverside, as we know now, but Riverside Ochre Company in 1905. And they began mining ochre here. And they were, and the original, if I remember, when ochre first started mining, there were like 2 ochre mines. And then there ended up, not too long after that, being 9 of them. And, but theirs was one of them, okay? You had Cherokee Ochre Company and Georgia Peruvian Ochre Company. You had quite a few of them. And some of the finest people that have ever come to this area came here because of the ochre mining business. Mr. E.P. Earl came here. He was a New York financier, and he sold ochre, and he got it from Peru. And I know you've heard this story, but he was coming through here on a train going south and went through a railroad cut, and saw what looked like ochre to him in the bank. And he just reached up and pulled the cord and stopped the train, got his bags, and got off. And that ochre was better than any of the ochre that came from Peru. So they started mining it, called it Georgia Peruvian Ochre Company. And Mr. E.P. Earl was one of the 5 builders and original owners of the Empire State Building. And he was quite a gentleman. And, but anyway, we got started in it, and my grandfather ran the company. And the shareholders were he and my grandmother and John E. Satterfield. They were the shareholders of it. And they mined, just kind of piddled around there for a while, you know, trying to do it the best way they could do it. And people would mine ochre and bring it and dry it in open vats, okay? And that's the way we used to dry it here, you know, just open vats. When it started cracking across the top, is when you looked like an alligator eyes when you dug it up and shipped it, okay? And the big market for ochre back then was what they called heavy linoleum. I don't know where the name heavy came from, but it was just a brown linoleum, probably about the color of this tabletop. And it was the only color linoleum there was. And it's called Battleship Brown, and it was the office flooring for all the offices in New York, Philadelphia, everywhere. That was it, you know. And there was quite a huge market for ochre in Scotland. A lot of linoleum was made in Scotland. So a lot of the ochre from Bartow County was shipped to Scotland for that purpose.
And, I had not heard that story. That's interesting.
Yeah. And, but anyway, getting back to it, the company was fairly successful. And in about 1920 or 21, my mother was 21 years of age. And my grandmother was a very, very particular type person. And I can't believe she did this, but she let my mother by herself. I can't believe my mother did it either. By herself, get on a train and go to Oklahoma. And that was some journey back in those days. And Mother's best friend had moved to Oklahoma. Her name was Florence Galt. And so Mother went out there to see Florence Galt. My father was a pilot in the Second World War. I'll say that. He had just finished his pilot training, and the war ended. So he went back to the University of Oklahoma to continue his education. And he was a member of the Beta Theta Pi fraternity, and they heard this Southern Belle was coming in, you know. And so they actually flipped coins, and the loser had to go meet my mother at the train station. And my dad lost. Okay, so he had to go meet her, and 2 weeks later, they were married in Oklahoma. So it was, they really fell in love with each other, got married and married in Florence Galt's home out there. Well,
I'm sure that created a ripple back here in Cartersville.
yeah, it really did. And the reason my dad came this way, and this goes back some, my father was born on an Indian reservation. And we found this out years later when my mother broke her knee and had to have her knee replaced. The best orthopedic surgeon in Atlanta was named Dr. Dunlap. And Dr. Dunlap was our company doctor also. So we had known him for quite a while. But we also found out in the hospital that Dr. Dunlap was born on this same Indian reservation. Isn't that kind of a twist? But anyway, my father was born on this Indian reservation. He wasn't a citizen of the United States until he was 7 years old. And my grandfather, Dellinger, J.P. Dellinger, was a real entrepreneur. And he was an Indian agent on this big reservation for the government. But in the meantime, he ended up leasing from the government the southwest corner, basically, of Oklahoma to graze cattle on. And he made a good bit of money. He was the first Ford dealer in the state of Oklahoma. But what he would do, he would build buildings in Tulsa and Oklahoma City. And when that building would get maybe 1/10 paid for, you know, he would get it refinanced, take that money and go build another building. And he just kept going. But back then they had the every 7-year recessions. And a recession would hit and boom, down he'd go. And he came back about 3 or 4 times. And the last time he said he couldn't do that anymore. And he moved to the little town of Ringland, Oklahoma. I've been there quite a few times. And it had dirt streets. And he opened a hardware store there. And the only hardware store in Ringland. And he ran that until the day he died. And they had and he died in 1956. I'd been out of the Army about a year when he passed away. And but anyway, my daddy looked at that little hardware store and he knew that my mama's family was in the mining business, and he thought this sounded a whole lot better to him than being in that little hardware store. So he came back here with my mother in 1921, and my grandmother, they said, was just nervous as she could be because all she knew about the West is what you read in those old magazines.
And
you know, they had
novels,
yeah, the comic you know, those things. And she thought my dad was going to step off the train with a handlebar mustache, a big hat on, and 2 guns on, you know. And she couldn't believe it when this real handsome, nice-looking young guy stepped off the train. So he was a hit with them immediately. And my dad got in the mining business here, and he was just a natural for it.
I was going to ask you.
Absolute natural.
He had no background when he showed up.
No background whatsoever, but he was a natural. And we mined ochre, and everybody knew the barite was around here, because at that time there was some on top of the ground, you know. But nobody mined it. It was really a hindrance to mining something else, you know. So they didn't mine it at all. And back in the First World War, your barium chemicals, the way I read it anyway, were made in Germany and shipped to the United States. Well, the war came on, and you couldn't get the barium chemicals from Germany anymore, so they started looking around for barite ore to make the barium chemicals. And the Cartersville barite deposits were some of the best they could find anywhere, and that's how people started mining the barite. And for years we mined barite, and we sold it a lot of it to DuPont. And DuPont made glass, and we sold a lot to Chattanooga Glass Company. They made the glass for the Coca-Cola bottles in this area, you know, for sure. And we had glass customers. We had one out in Sapulpa, Oklahoma, and Ada, Oklahoma, and they all made Coca-Cola bottles and that kind of stuff. And the reason they liked the barite from here is because it had just enough iron and manganese in it to give the glass that green color that a Coca-Cola bottle has. You know, they don't have it now, I don't believe, but they used to have that green color. Anyway, I don't want to get ahead of myself here, but my father, there was a guy named Mr. Daly, and he was a purchasing agent for DuPont. And my daddy went up there to see if he couldn't sell some of his ore to DuPont for their glass. At that time, it was all coming from Thompson Wyman Company. And he said, I'll tell you what, he said, you can have all the business if you can produce, he said, we want an ore that's going to run 95%. And we don't mean average 95%. He said, we get it from Thompson Wyman and others in that area. One car will be 93%, the next will be 97%. And we can't set our furnace conditions there. We want 95%. So my daddy, without having any idea he could do that, he said, I can do that. So he came back, and the way he did it, where he knew he'd make at least 95, you know, and try to make it right on the head, he instituted putting a picker belt on it, the washer. And it's hard to describe to you what a picker belt is, but when the coarse material comes out, you've got guys there picking the barite away from the rock. And dumping it back in, you know, instead of letting it all go back in and be ground up, you know. And by doing that, he was able to control it pretty much at 95%, and he got all of that business, every bit of it. And that was wonderful for a while. And one day, Mr. Daly called him up and said, you need to come up, I need to talk to you about something. He said, you may end up losing all of your business to us because of a competing pigment, and that was titanium dioxide. They used the barite for lithopone, in paints a lot too, okay? But titanium, and DuPont was big in paints, so they used a lot of it for that. And lithopone would make a paint that was thick, and it was hard for the painter to draw his brush through it. You know, he couldn't get a lot of laps in without having to dip back in and do some more. And after a while, the lithopone would start to oxidize. And in about 8 or 9 years, or 7 years, I think 7 years was the time period pretty much, what used to be a white building became a kind of yellow-looking building. It wasn't very pretty, you know, and you'd have to paint it again. Well, titanium dioxide, you put it in with the oils, and it gave a much whiter white. It gave a much thinner paint that the painters could really brush back and forth with, and it would never oxidize. So he told him once the titanium dioxide comes down enough in price, lithopone is going to be pretty much a thing of the past. It didn't end up that way, but that's what he thought, thing of the past. And how you make lithopone, you take, I'm not sure exactly how they did it, but you take barium sulfate, which is our barite, and zinc sulfide, and you combine those two together and you make what they call lithopone. And it's still made some in Germany. And there's some companies that take lithopone and titanium dioxide, TiO2, and blend those together and make kind of a middling type product. But anyway, my daddy took Mr. Daly at his word, you know, that he was going to that we were going to lose that market, which ended up happening. And he looked around for another market to get into, and the only other thing was drilling mud, for oil well drilling mud. And that's a feast or famine market. If they're drilling for oil, it's good. If they're not, it's bad, you know. So, and the price wasn't too high either. It was a commodity market. So he looked at barium chemicals, okay? And so in 1934, we started Chemical Products Corporation. And we started it on the other side of the river from where we are now, along the Loop Road. You know where that, around the bridge, the old bridge that goes over, okay? And to this day, Halliburton is having to clean up, I guess, some of the, they say mess that we left there. And if you'll drive by there, you'll see where they've dug all the earth out, processed it, and putting it back in and all this kind of stuff, you know. And presumably, we left something there that messed it up. I don't know what it could have been, all right? It was funny. But I can remember going there when I was a child. I'd be 4 or 5 years old. I guess it started in 1934. And my uncle, Cobb Ferguson, was the chemist there. And he knew about as much about chemistry as I did, probably at 5 years old. He did graduate from Emory, but he didn't have any chemistry classes, okay? And you could take nitric acid. I had no idea what he was doing. He'd ask me to bring him a whole bunch of pennies. And I'd bring pennies, and he'd put them in the nitric acid in a basket. and bring them up, and they'd be brand new. It would take all the oxidation off of them, and I thought he was the smartest man I'd ever known in my life. Okay, but we started off that company in 1934, and it was so crude that we actually precipitated the barium chemicals, barium carbonate and barium chloride, in bathtubs. And we chilled the bathtubs, and that's how we precipitated it. So we could never really make a quality product, so we had to sell it on basically the second-hand market.
I've heard of a shoestring operation, but
it was a shoestring operation, it really was. And it was that way for quite a few years. And chemical products never made any money, basically until about 1941. They went 6 or 7 years really struggling. And of course the war came on, and there was a demand for barium nitrate. And they needed barium nitrate for flares. Barium nitrate will flare green, I believe it is, and strontium nitrate flares red. I think I'm giving the right colors there, okay? So those were the two colors for your tracer bullets, okay, for your incendiary bombs, and for the flares that they would, when bombers would go over to bomb a target at night, they wouldn't be able to see that target. So they would drop flares from the bomber that would burn real bright, and it would light up the target, and they'd drop the bombs on the target. So we actually had a captain here, I can't think of his name now, but he was from New Mexico, and he was with the Chemical Corps, the Army Chemical Corps, and he was stationed at Chemical Products for the duration of the war to make sure that they were producing the stuff up to standards. And when I went in the Chemical Corps, which would have been in 1953, I was sent to Edgewood Arsenal, Maryland, that was the headquarters for the Chemical Corps. And here I was, this young second lieutenant. I wasn't there 2 days until I get a call that a colonel wants me to come over to his house and have dinner. And that, I couldn't believe it. So we went over to his house, and that colonel was the captain that was stationed at Chemical Products in that time. And he had seen a Dellinger on there, and he figured out I just had to be, you know, and James R., and my daddy was James R. And he wasn't too happy with being in the Army because he was called back in for the Korean War. I mean, he had been in business privately for himself in New Mexico all these years, but he was a full colonel, and so he was very nice to me, and we had a wonderful time in the Army because of that. Yeah. And the funny thing was that Chemical Products had never made any money. So all of a sudden they started making money during the Second World War. And they came on with an excess profits tax. And that meant anybody that was making money off of the war, you were penalized for whatever you were making above what you were making prior to the war. Well, we weren't making anything. You know, so in fact, they were losing money. So they went through the period of that where they got their profits, a lot of it taken away from them, simply because they were losing money before the war ever got started. But from there on, they went on to become probably the most successful barium chemical company in the United States. And that business and our barite business has become, it's made changes I never thought I would see in my lifetime happen. It used to be the big, you might say, cash cow for all the businesses, and it's really not anymore. Number one, the Chinese started competing very heavily in barium chemicals. In anything where barite's used, you know. And so the price of barium chemicals and barite ore has been kept artificially low for years and years, and because of this. And now it's gotten to where our main customer, one of our main customers for the use of barium chemicals, it goes in the faceplate of all cathode ray tubes, like the old thick television tube, you know, and it shields you from radiation. In addition to giving the glass a better hardness, which is an annealing feature that gives a brighter picture. It makes a brighter glass out of it. But the main thing, it shields you from radiation. It'd be just like you'd be sitting in front of an X-ray machine if you didn't have that in there, okay? Well, all of the customers for that glass in the United States and Europe have all left, and they've all gone to Taiwan, China, Korea, Japan, you name it. So the customers are gone, you know. In addition to that, they come out with the new flat TVs that are about that thick, and they use very little of this in their faceplate, very little. So the market just vanished, basically. And we have had to reinvent ourselves. And now we went through about 2 years of really hard times, and now we're just doing great again.
Good.
Because we've come on with specialty barium chemicals that the Chinese don't compete in. And in addition to that, one of the businesses that we've had where you sell the barium chemicals is growing very well, and that's in ceramic magnets. And a ceramic magnet, they can either be flexible or barium, strontium, ferrite magnets, or they can be hard, okay? And the flexible ones would be the ones that you stick things on your refrigerator with. You know, those, somebody will give you their business card and it'll be a magnet. You can use it to stick on the refrigerator with. Or you can have a little apple with a little hard magnet on the back of it, stick something on the refrigerator. That's a big market. And the flexible ones are the ones you see on the back of all the cars that say support your troops, you know, in the line, or support cancer research, the pink ones, you know, all that stuff. And your refrigerator gaskets, they are flexible magnets. One's positive magnets, one's negative. And when you close it, you get a perfect seal.
How much competition elsewhere do you have against you with that?
Not a whole lot.
Good.
Thank goodness. And but the other people make magnets too, other than in the United States, you know. But we're doing real well in that business, and the business is growing rapidly. And the nice thing about the magnets in the refrigerator doors, you know, you used to hear about children get in an abandoned refrigerator and suffocate because it had a latch and you couldn't get the door open. They could get in, but you couldn't get open, you know. Well, now you don't have to worry about that. If they throw a refrigerator away in a landfill or whatever, or by the side of the road, you can get in and out easy, you know, unless it happens to be an old one. But another major use of those magnets, really major use, at one time there were 30 ceramic magnets in every automobile made in the world, basically. And now Ballard Mullen was telling me the other day it's either 63 or 83, I forget what it is. So that's, the demand has increased tremendously. And what that's used, how they use that is interesting. They fire these magnets and there'll be little bitty circles, like a donut, just like a donut, okay? And the inside will be one of the charges, either negative or positive, and the outside will be the opposite charge.
Okay.
And you create a magnetic field. And you cut that and you can create your electricity. And it's used for everything in your automobile, from operating your windshield wiper motors to your heater, to your air conditioner, to your the little red light that comes on that's shaped like a gasoline tank that shows you running low on gas, your window motors, your electric locks, your seat sliding back and forth in every which way, you know. That's all ceramic magnets, where it used to be a little copper wound deal that basically your handicapped children were employed to do that, and it took a long time for them to switch over because of that, you know, because of the human aspect. But they had to because of the CAFE rules that demanded they go from 12 miles a gallon up to 23 miles a gallon average. So anything they can do to decrease weight, they do.
Interesting, yeah.
And this decreases the weight. And Ford Motor Company has been trying to come up with a starter motor with a ceramic magnet, which would be a big one, you know. But they have never been able to do that. They haven't done it yet, you know. But that business is just doing great.
Good.
And our ochre business at New Riverside is doing fine. Our barite business has almost gone away. We were in ground barite for a while, but now we're not big in that anymore.
Are you the last man standing in the mining business here in the county?
Well, except for Vulcan Materials. I mean, you know, in the quarry business, I can't think of anybody else.
I can't think of anybody either.
I dream at night sometimes that somebody's opening a barite mine and somewhere that I didn't know anything about, and it's in Bartow County, you know, and I kick myself turning that piece of property down. All right. But anyway, no, I think we're the last. I think I'm the last Mohican, the last one standing. You're right. Yeah.
Jim, I remember hearing from some source, probably erroneous, that that you got into something of a tight bind with the Environmental Protection Division over that the Etowah River was looking pretty murky, and they thought you had something to do with it. Would you?
Yeah.
Is that a myth, or is there some substance there?
a lot of substance. They thought we had something to do with it, and we absolutely had something to do with it. We had always taken our tailings from our washer plant, okay, and put them in the Etowah River. And as far as I know, they went on and ended up in Mississippi. I don't know where they ended up, okay. But then they built Weiss Dam and started damming that lake up. The carpet people had always put all their dyes in the river that goes by them too, you know. So there you had carpet dye and mud meeting. It didn't look too good. And but the environmental, what they really started to clean up, what they wanted to do is, you know, Cartersville, especially Rome, Georgia. I mean, they put all this sewage in the river too at one time. I mean, you know, the rivers were pretty dadgum polluted, and put a lot of waste in the river. Okay, well, they were trying to get the sewer plants up to snuff and all that kind of stuff. That costs a lot of money, and they see this little miner here, and they know what he's doing, you know. So they started to really clamp down on us. They were going to make an example. We were going to be the first one that's going to have to take our stuff out of the river. So Bill Quillian, who was a doctor here and a very good friend of my dad's, one of his best friends was a Dr. Venable. And they had appointed Dr. Venable to be the first head of the Water Quality Control Board. He calls Dr. Venable up and says, this nice young man's going to come down and testify before y'all. Give him a shot, you know. So Dr. Venable was real nice to me, and we had a room crowded full of people. And this guy gets up and says he caught catfish out of the Etowah River, and they tasted muddy. And I'm young, and I'm, you know, 33 years old, I guess, about 1960, 1963. And I asked the guy how he knew what mud tasted like. You know, I told him I didn't know that wasn't a nice thing to do, but, you know, I did anyway. And I told him that, you know, the name Etowah meant muddy river, you know. And man, that made the headlines in the Atlanta paper, you know. Etowah means muddy river and all that kind of stuff. Well, I didn't know what it did or not, but I didn't know who knew what it meant. And then Miss, what's her name? Felton, who wrote the history of Lucy Conyers.
Lucy, yeah.
She comes out and says Etowah means high tower. And she's wonderful, and she did a great history, but I don't think she has any idea either, if you want to know the truth. I mean, where would Hightower come from on the Etowah River? But anyway, that actually happened. And but we were the first people, as far as I know, in the state of Georgia, to take their effluent out of the river, out of any river. And we built a tailings pond on the Smith Mansfield property that lasted us for years and years and years, and we put nothing but pure water back into the river. And we've tried to do the same thing ever since. You know, we had a big tailings pond up where Highway 41 goes by, and we've actually received commendations from not only the environmental people, but from the Business Council of Georgia on the job we've done and so is Chemical Products, to control our pollution. So once we found out what we really had to do, we jumped in there and got the job done.
Good,
you know, okay, yeah.
That's a great story.
Hello, I'm Stan Bearden. I'm a geologist with the New Riverside Ochre Company and currently serve as Vice President of Operations. Jim has asked me to come by and share a little bit of information about the geology and the mining history of the Cartersville Mining District, and I'm glad to do so. I've been with New Riverside for 30 years, coming straight out of studying geology, and I've had one of the best careers of any professional geologist with whom I'm aware. Been able to travel all over the world. My specialty field is economic geology, which means that study of earth science where you study the earth, try to find mineral resources that can be mined and sold at a profit. And that's the business that we're in. We're fortunate to be in Cartersville because the Cartersville Mining District is one of the oldest mining districts in the southeastern U.S. that's been continuously active. We've got a very long history that predates the Trail of Tears. Gold was one of the first minerals produced in this district, followed by iron ore, and then both of those, of course, were before the war between the states. And after the Civil War, other ores such as spectrohematite, carbon, and most importantly now, barite and ochre have been mined, as well as manganese. This district is known not only nationally but internationally because of the variety of minerals that have been discovered and produced here. This area has been studied by geologists for well over 100 years. And in our library and at the Future Tellus Center at the William Wyman Mineral Center, you can find books that were published well over 100 years ago that highlight the Cartersville Mining District.
Stan, why don't you tell them about some of the old rocks around here that you tell me about, huh?
Really interesting. Bartow County and Cartersville, if you're familiar with the local geography, the most interesting communities in the county, to me, geologically, would be those of Roland Springs, downtown Cartersville, and downtown Emerson. And it's because those three communities, if you draw a sinuous line, they're not linear, but if you draw a line along those three communities and extend it northward, paralleling and approximating the path of U.S. Highway 411 all the way up to Tenga in Tennessee, what you have done is draw a line through the eastern one-third of the county. And that line, on the eastern side of that line, are rocks that we call igneous and metamorphic rocks. And all those rocks which lie to the west and south of that line are sedimentary rocks. Sedimentary rocks are those rocks that were formed from material settling out through water. And these can be dated either by a paleontologist who's familiar with the life forms that existed at the time, or by stratigraphic relationships, and by that we mean the way the rocks are related to each other. For instance, when your mother bakes a 3-layer cake, the very first layer she puts down is the first one, and it's the lowest one on the cake. The top layer is the youngest layer. Well, the same type of description can be made of rocks. In an undisturbed sequence of layered rocks, the one at the bottom is the oldest, and the one at the top is the youngest. This area has been studied for so long, and it is now fully embraced and understood by the scientific community that this area that lies west and south of that line was at one time covered by a marine ocean. And that ocean was no deeper than 100 feet in thickness. And the reason why we know that is that there are fossils that exist now in these rocks, and these fossils are called index fossils. They're fossils, and a fossil is evidence of pre-existing life. And these animals that lived in that ocean lived on the bottom of the ocean floor, but they could only live in that area that was called the photic zone, where sunlight could go through the water, hit the bottom of the ocean floor. And these fossils looked like what we now call coral. They were animals that lived at the bottom of the ocean floor, but these animals became extinct. And they lived only from the period of time of 540 million years ago up to 570 million years ago. So during that 30 million year period, these animals existed at the bottom of the ocean floor right here in Cartersville. That ocean floor produced a rock that's now being produced in all the marine environments called limestone. So the limestone here that contains the fossils.
What's the name of that funny fossil you talk about?
That is called an archaeocyathid.
Thank you.
Archaeocyathid.
And I have one of those, right?
Yes, sir, you do.
Okay, good.
In fact, we also, anytime we find those, we save them and we give them to school groups.
Oh, great. Okay.
Now, the very best samples that we've discovered from our mining operation are now at the William Wyman Mineral Center.
Right.
Well, those archaeocyanhids are enclosed or encased in the limestone. And that happened about 550 million years ago. Well, since that time, younger rocks were laid on top of that limestone. If you drive along Highway 41 from Cartersville, just past the Humana Hospital, and you're driving along and you approach the intersection of 411 and 41, there's some construction going on there now, and you will see, instead of red clay and brown clay, all of a sudden you can start seeing shale, layers of thin hard rock that are eye-catching because they're multicolored. They can be lavender, red, or buff. Well, that formation is called the Rome Formation. It's younger and it overlies the limestone that has the archaeocyanhids that's called the Shady Formation. And the Rome Formation, in fact, there's a sample of it right over here. It has textures that prove that it was shallow marine because we have something that's called oscillation ripple marks in it.
Like waves? Like,
Yes, sir.
Like you wave?
In fact, when a wave happens, the surf breaks. If you're on the beach and you see the surf coming in and it breaks, that means the wavelength, the energy created by that wave, gets so strong and the sea gets so shallow that that oscillating energy can hit the bottom of the ocean. When that happens, the wave breaks and you have surf. Well, the Rome Formation occurred in a marine environment like that, very shallow. What's really interesting, though, and what makes the Cartersville mining industry exist here in the Cartersville Mining District so interesting geologically, is that since that time when these rocks were deposited 550 million years ago, there has been some collisions on the plate tectonics. The Earth, you can imagine the Earth as being a round ball that's surrounded by a jigsaw puzzle. But let's say these, instead of having 40 or 50 or 100 pieces of the jigsaw puzzle, there's only 40 to 70, depending on which geologist you believe. And these plates are floating on the mantle of the Earth just like a piece of styrofoam would float on a swimming pool. And they bounce together. And these pieces of jigsaw puzzle are what we call the crust of the Earth. And what happens when these pieces of puzzle bounce together, mountain ranges are formed. If you look at a globe of the Earth, you'll notice that from the Aleutian Islands all the way along Alaska, through Washington and Oregon, where Mount St. Helens is, down the eastern coastal mountains, San Andreas Fault, all the way down through South America. That's a continuous mountain chain, and that's because North America is bouncing against the plate of the Pacific Ocean. Those two pieces of jigsaw puzzle are bouncing together.
Well, the Appalachian Mountains were caused by the same type bouncing, wasn't
You're
it?
exactly right.
Okay.
Yes, sir. We have earthquakes and volcanoes now on the West Coast.
Right.
At one time, we had those here.
Right. Well, I've always understood, okay? We have red clay all over North Georgia. We're known for our red clay. But the red clay did not originate here. I mean, didn't it come from higher elevations in Tennessee and maybe upper North Georgia from erosion?
Yes, it
was
did.
all washed down here and overlays the limestone and what have you?
It does. Rocks will decay in the environment.
Right.
And rocks are the material which produces dirt and soil. All dirt and soil comes from the decay of rocks. It's enriched at the top layer with organic material that we call humus. But the red clay, Georgia's known for the red clay because it did wash from higher areas to the north.
Right.
And those rocks contain small amounts of iron. And iron will oxidize or rust. So the clay that's produced from iron-bearing rocks will produce red clay.
Right.
And the reason why it's so prevalent here in North Georgia, and especially in Cartersville, is that the plate tectonic activity that we now observe on the West Coast happened here. On the East Coast of the U.S., if you ever look at a globe, and you'll see where South America can snuggle next to Africa, like two spoons, they fit together. Same thing with North America. At one time, we were joined by the north coast of Africa and Europe. In fact, some of the fossils that you can only find in Morocco on the northern coast of Africa, you can find in Georgia.
Right.
It's known at one time we were one landmass, but those pieces of jigsaw puzzle widened, came together, bouncing together, and formed the Appalachian Mountains. When that happened, these rocks here in the Cartersville Mining District were deformed. They were folded into high mountains. At one time, the Appalachian Mountains were higher than the Himalayas.
Yeah. Well, let me ask you something. The shale, there used to be a brick company in Plainville, Georgia, and it was called the Plainville Brick Company. And that shale, I assume, that they made the brick from, was that the Rome shale?
No, sir. That was the Conasauga shale.
Okay.
And it's actually younger than the Rome shale.
Okay.
There's a difference. To make things out of rocks, those rocks have got to have certain characteristics. And the Rome shale has got too much sand in it. But the Conasauga shale is much finer grained, and it's highly sought after for the making of brick and tile.
Okay.
But when those plates collided in this area, one of the plate was shoved on top of the other plate. And it's known that when those conditions exist, you have a fault. and it's called the Cartersville Fault.
Right.
The reason why it's called the Cartersville Fault is that it was first described and understood in detail here in Cartersville at the base of Alatoona Dam. And as geology continued to evolve and other geologists in other parts of the country were studying the fault, they came to the conclusion that they can't call it the Cartersville Fault everywhere. They call it the Great Smoky Mountain Fault, because it goes all the way from Maine through Cartersville, Georgia, and then bends to Tuscaloosa, Alabama. And it's a break in the Earth's crust that at one time, there's no doubt, was much greater than the San Andreas Fault ever has been or ever will be. When that break happened, that fault, deep inside the Earth, there were warm solutions called hydrothermal solutions that came in from the mantle. And those hydrothermal solutions were enriched with elements, one of them being barium, the other being iron. And that's the reason why the Cartersville mining industry is unique, because we've got unique geologic conditions, as well as very good mine operators.
Well, let me ask you this. I've been told that beneath the bedrock, the limestone bedrock, that there's a possibility for numerous sulfides to exist down there. Silver sulfide, gold sulfide, zinc sulfide. Do you feel that's a possibility that someday might be
absolutely
explored?
Absolutely. It has been demonstrated by Amoco.
Yeah, when they did the drilling,
doing some drilling here in the early '80s. They were here because economic times were good for gold, copper, and zinc. And during those good times, major mining companies will invest a lot of money to try to find where deposits may occur.
That's correct. Yeah.
So they came here and they drilled deep holes. In the mining of New Riverside, we did drill holes that are anywhere from 100 to a maximum of 300 feet in depth. Well, Amoco drilled holes that were thousands of feet in depth. They went through the weathering zone into the hard rock, beyond the limestone, beyond the shell, and they proved that the iron that's here is here because there's fool's gold or iron pyrite enclosed in those rocks at depth. And just as water will make rocks decay, water will change that iron sulfide to iron oxide.
That's it. Very interesting.
Jim, I've been fortunate to have worked at New Riverside for 30 years. It's been very rewarding, personally and professionally. But having been in the business for 30 years, I know that there's very good times and there's tough times.
That's correct.
You've taught me a lot, but there's still a lot more that I've got to learn. Could you tell me something about your feelings on the...
Yeah, I'm not going to tell you about tough times, but I'll tell you how I feel about the company in general. From what all I read, and I think it's very true, it's very rare for a family business to go for more than one generation. Things happen. Children don't get along well with the father, or they aren't interested in the business, tax problems, and they sell to a larger company or to somebody else, you know. And I think it's rather amazing is that now, two of our daughters, Dee Bishop and Marlo Smith, are very interested in the business. And so this is the fourth generation that this business has existed with, and I think that's a fantastic record. There are a few companies I know that can say the same thing in Georgia, one or two, but very, very few. And I just think that's amazing. And, you know, our son, Ray, he was our only son, he got his degree in economic geology also. He went to the Colorado School of Mines and had a conflict there. It's understandable. He was a young man, and the Coors Beer Factory is right across the street from School of Mines. Plus, he loved to ski, you know, and the slopes out there have a lot of snow on them. But anyway, Ray wanted to come back, so he came back and finished at West Georgia. And he was out here working with us for 2 or 3 years, and he did a great job. But I could see that he really wanted to do something else, you know. And the automobile business was right up his alley. He was a great salesman and great people person. And as you know, he migrated to the automobile business. And then unfortunately, Ray lost his life on I-75 when he was 29 years of age. Ray would be 51 years old this year on December the 16th. But anyway, no, not on December the 16th, the day he lost his life. He would be 51 in May this year. He would be 51, and you know, it's a shame. So we have 3 daughters, and Dee, Marlo, Debbie, and then Judy and I, our second marriage. We've been married 26 years. We have a daughter, Mandy, and Mandy is getting her master's degree, graduates May the 12th from Georgia State University with a perfect 4.0. In fact, she's going to be #1 in the class in child and adolescent psychology. And she really wants to practice in a treatment home environment. That's her bent right now, you know, and everything. Debbie has raised some wonderful children. In fact, Debbie's the oldest daughter, the oldest child. Debbie was born up in Maryland, and when I was in the Army, and Debbie's daughter Leah, who is absolutely beautiful, is getting married September the 15th, and she's asked me to walk her down the aisle, and that brought tears to my eyes there, you know, everything. And then, of course, Dee is busy raising children. Marlou's busy raising children and running a gym. She's got the Bodyplex gym here and is just doing a fantastic job with that. And she can't drag her daddy into that gym because if there's one thing I do not like is planned exercise. I don't mind what, but I do go occasionally because I get feeling bad about it. But I'm very proud of, and Jamie, I've got a grandson, Jamie, who was raised, the son I lost, raised son. Jamie is with the Capital Research Group in Washington, D.C. In fact, he's a vice president of his own, and he will be 25 years old, his upcoming birthday. I think that it's in April, but I'm not going to give you the date right now, okay? Because I lose track with 10. But anyway, but Jamie is just doing a fantastic job with him. He's just smart as a whip. And where he gets a lot of height, Jamie's about 6'6", and wears a size 14 shoe. I mean, he's a big boy. And Jamie went to George Washington University, and they're well known for their crewing, you know, their rowing. And Jamie was a fantastic high school rower, and he received the only full rowing scholarship that George Washington has awarded in maybe 15 years.
Wow.
And in addition to being with the Capital Research Group, he's also there's a university they call American University, and he is he's the coach of the ladies team. So all the children and grandchildren are just doing great.
You have one grandson, I believe, who's at New Riverside working on his 6-month
Yes, I do.
employment.
Yeah, I do. Yeah, Luke. And Luke can come out of that ochre mill. He's packing ochre. And Luke's about 6'2" or 6'3", and wears this big white coverall thing. And I'll bring him occasionally he'll forget his lunch, and he'll call me, and I'll bring him his lunch out here. And he looks like the abominable snowman, you know, he does. And how he gets any ochre on him through that, I don't know. But when he takes that off, and I see him after work, he's still got ochre on his clothes, you know, but he absolutely loves it.
Yeah.
Luke loves working. He's very proud of what he's doing. He absolutely loves it. Thank you for asking me about Luke. Yeah. And Luke will be 21 his next birthday, which is, he's the perfect poker player. He's born on 7/11. So 7/11, you know, so I can always remember that. But he'll be 21 years of age. All right. Thank you. I've enjoyed this very much. I want y'all to know that, okay?